Okay, so for similar figures, some figures have the same shape but different size. They are called similar figures. Okay, so what's the requirement for some shape to be similar shapes? First of all, like for example, if you have hexagon, the other shape must be hexagon as well. You can't say hexagon and pentagon are similar shapes. Second, all the corresponding angles must be the same. Okay, all the angles must have the same size. And another one is all the corresponding sides should be in the same proportion. So for example, you have a rectangle. For that rectangle, the length, so we have rectangle number 1 and we have rectangle number 2. So to say those two rectangles can be similar shapes, if I have this length is 4, this is 2. Okay, the length is 2 times as the other one's length. So the width must have the same proportion. So if that is 3, then you have 1.5 for that one. Okay, you have 1.5 for that one. So length divided by the longer one divided by short one is 2 times. So that should happen to the width as well. So, and all the angles are 90 degrees. So all the corresponding angles must be equal. So they are similar shapes. So we have an idea of scalar factor. We can call this length scalar factor. Okay, we can say that's length scalar factor. So how many times the larger one to the smaller one, or how many times the smaller one to the larger one, must be the image of the original. Okay, must be the image length over the original length. It doesn't matter which one is larger, which one is smaller. You just need to say which one is the original and which one is the image. Image on the numerator and original one under the denominator. Say if we have that is the original and that is the image for that two rectangles, then we will have length scalar factor equals to the image, which is 4 over 2. That gives you 2. So the length scalar factor will be 2 for that group. Like why I use length, it doesn't really matter which pair you use. You can use both widths. Because all the pairs will give you the same scalar. So they are in the same ratio, so they can be similar shapes. So I can use 3 divided by 1.5. That will still give you 2. But you cannot use the length to divide by the width. They are not corresponding pairs. Okay, so we use the symbol like 3 vertical lines, or we can use this one to represent they are similar. I can say rectangle 1 is similar to rectangle 2. Okay. If you're late, make sure you get a late pass, please, everyone. Okay. Rectangle 1 similar to rectangle 2. Okay, so all we can say ABC is similar to DEF. Okay, so we can use 2 symbols. Doesn't really matter which one you use. Okay, let's have a look at example 1. In example 1, these 2 shapes are similar. Okay, the first information I tell you that they already they're similar shapes. So the information you will know will be 2 informations. All the corresponding angles must be equal, and all the corresponding lengths will be in the same ratio. Okay, that's the 2 things you will know from similar shapes. Okay, as long as they are similar shapes, you have those 2 properties. So find the scalar length. Okay, find the scalar length. So first of all, I will find out what are the corresponding pairs. So which pairs are the corresponding pairs? This one is kind of like hypotenuse. So that one, they must be corresponding pairs. Okay. And the one opposite to that will be corresponding pairs. Okay, those 2 must be corresponding. Okay, it's very obvious the slant height will be the one corresponding, and the opposite one must be corresponding. Okay, we have CB is the shorter one from the two parallel ones, and FG is the shorter one from those two parallel ones. So those two must be corresponding pairs. So shorter ones, they are corresponding pairs. And the last one left is this one and this one. They must be corresponding pairs. So find the scalar length. Okay, from the blue pair, I can't have any value. There's no values for the two blue parts, so don't need to worry about that. From the two green ones, we have y and 7. I can't really find the numerical value. So there's no numerical values for the shorter one, so it's a y. I can't find out the scalar length. See the two black ones, I have an x in the longer one, so I cannot find numerical values. So the only pair we left is the two red ones, which is 2 and 5. It's very inconvenient if I'm not giving you which is original. Let's say that's the original one, and then that must be the image. I should put this information on for you. So original one and image. So number 1 is scale length. So scalar length factor equals to the image over the original. So which one we said we will use? We'll use the red pair. So it's 5/2. Okay, it's 5/2. Okay, part 2. Find the value of x and y. Okay, find the value of x and y. How we should find that? If we have the scalar length factor already, we can use that ratio to find all the other pairs. So let's see the green pair. The green pair is 7/y. Okay, 7/y is the green pair. That will give you the scale factor. So the scale factor, I already know that's 2/5. So cross multiply. 5y equals to 14, and y gives me 14/5. Okay, that's how we can find this y. And how we should find x. X is included in this black pair, so x/3 should give you the scalar factor, and the scalar factor is 5/2. That should give you 2x equals to 15. X is 15/2. Okay. Number 3. If the area of the smaller shape is 4 centimeters square, find the area of the larger shape. Okay, it's not length anymore. It's talking about the area. So I want to extend here a little bit. So we have length scalar factors. We can also find area scalar factors. Okay, what's area scalar factor? Area scalar factor should equals to the area of the image. Okay, they must be similar shape as well. So equals to area of the image over the area of the original. Okay, area of the image over the area of the original. That should give you area scalar length. Okay, that should give you area scalar length. So what that should be? That should be the length scalar factor squared. Okay, that should be the length scalar factor squared. So let's say we have the length scalar factor 5/2 here. Then the area scalar factor will be 5/2 squared. That will give you 25/4. Okay, that should give you 25/4. So the area scalar factor will equals to 5/2 squared in this question, and that is 25/4. So the area of the image over the area of the original, that should give you a proportion 25/4. Not enough space, so I'll write here. So what's the area of the image? Let's say it's giving you the smaller one is 4. So the smaller one is the original one. So the area of image over the area of the original is 4 already. It tells you it's 4 because it's the smaller shape got area of 4, so that one got area of 4. So the area of the big one on the area of the smaller one is the area of the image over 4, equals to, that should give you a proportion of 25/4. That should give you 25/4. And the area of the image must be 25. Just times 4 on both sides, that gives you 25. So the bigger one will get an area of 25. Okay, I use the scalar length to find the area ratio. So I know the area ratio, I know one of the area, I can find out the other area. Okay, so that's how we do this. So this area will be 25. Okay, want to extend here a little bit more further. So we have length scale factor, we have area scale factor, we can also find the volume scale factor. So if two 3D shapes are similar to each other, so let's show one example. Let's say we have two cylinders. I have cylinder number 1. I have a smaller one here. Okay. How those two can become similar shapes? If I have, okay, so what decides what the cylinder looks like is the height and the radius. Okay, it's how big at the bottom and how high of the cylinder. So let's say we have radius of 6 here, and we have a 12 of the height. Okay, I have 12 is the height. So for this one, if we have the height is 4 and got a radius of 2. So 6 divided by 2 is 3, 12 divided by 4 is 3, so they have the same proportion. Okay, they are the same shape, they are all cylinders, and the height and the radius in the same ratio. Then those two cylinders are similar cylinders. Okay, if they are similar cylinders, okay, if they are similar cylinders, we have two things to talk about. Okay, first, the length scalar factor. Let's say that's the image, that's the original. Okay, the front one is the original, the second one is the image. The length scalar factor will be 2 on 6, and that will give you 1 on 3. Okay, so that's this length scalar factor. In the 3-dimension shape, we are not talking about area. We talk about surface area. Okay, we talk about surface area instead of area. Okay, so it's still like all the faces adding together. So the surface area scalar factor equals to 1/3 square. Okay, so if we talk about area, area will be square of the scale length factor. So the surface area scalar factor will be 1 on 9. So the total surface of the image over the total surface of the original, that will give you 1 on 9. Okay, so if 3-dimensional shape, another thing we'll talk about is the volume. The volume scalar factor equals to 1/3 to the power of 3. Okay, it's this volume, we cube that. Okay, the scalar factor, we cube that. Let's say the volume of the larger one is 9 centimeter cube. What's the volume for the smaller one? Okay, what's the volume for the smaller one? So we will know that the volume the volume of the image over the volume of the original, but the original one is 9. Okay, the volume of the image over the volume of the original one, which is 9. That should give you V of original, V of image over the volume of the original. That should give you the volume factor, which is 1/3 to the power of 3, which is 1 on 27. 1 on 27. Then volume of the image, which is the smaller one, should be times 9 on both sides, which is 1 on 3 centimeter cube. So the volume of the image should give you 1/3. Okay, times 9 on both sides. So the volume of the image is 1/3. So when you know the length factors, basically you know everything. Okay, if you know the length factors, basically you know everything. Okay, any question about this? We have different similar shapes and we talk about the scale factors, area factors, volume factors, and if we know one thing, we can know all the other things. Okay, if there's no problem, can you have a look at the next question? Well, before we start the next question, I will go through the next exercise, all the because it's talking about similar triangles, for example, too. So I will go through to prove similar triangles. So you need to know what are similar triangles first. Okay, we learned that in year 9. Okay, we learned that in year 9. So similar to congruent triangles, there are 4 ways to prove 2 triangles are congruent triangles. Can you remember what are they? Let's make a box here. let's say we have left-hand side is the congruent. And the right-hand side is similar. Let's go to revise what things can be congruent triangles. So we have the first one is SSS. Okay, the first one is SSS. The second one we have SAS. Okay, if two lengths are the same and also the included angles are the same, then those two can be congruent triangles. And we have AAS. Okay, why I write AAS? Actually, we have one condition. We have actually it's AAAS. Do you agree with that? Because we have two pairs of angles already equal, then the third pair must be the same. Okay, so actually we talking about AAS is talking about AAAS. All the three angles they're all equal, and we know one corresponding pair is equal. Then those two are congruent triangles. We say we know three things, AA and S, but actually we know four things. It's AAAS. Okay, so that's this one. Okay, the last one is RHS. If you have right angle triangles, hypotenuse are the same and the side are the same, then they are congruent triangles. Okay, that's four conditions here. Okay, I have four conditions here. Let's go to have a look. There are four rules for similar triangles as well. Okay, so for the first one, three corresponding angles are equal, AAA. Okay, remember the two pairs of corresponding angle equal, that implies the third pair of corresponding angles also equal. So you just need to say two pairs equal, then the third pair will automatically equals to each other because it's 180 of the summation. Okay, if we know three angles are the same, then we will know that those two triangles are congruent triangles. We don't need any information about the length for this case. Okay, we don't need any information about the length. For congruent triangles, you always need to know at least one length, but for this one, we don't need any length. But if I can match them, I can match them as this one. Okay, if I can match the conditions, I can say that's the AAA condition. Okay, I can say that's the AAA condition. Okay, we know similar kinds of information here. Okay, we know similar kinds of information. Okay, number two, all pairs of corresponding sides are in the same ratio. Okay, same proportion. Then we have similar triangles. In other words, like we don't need to know any information about the angle. Okay, we know six lengths in total, and we can pair them, and they are all in the same ratio. Then that will be similar triangles. So if we match them, they can be the SSS case. Okay, that will be the SSS case. So we have AAA and we have SSS. Okay, next one. Two pairs of corresponding sides are in the same ratio. Can you see AC and DF are in the same ACDF, and AB and DE are in the same ratio, all are in the ratio of 1:2. Then also the included angle must be the angle included have the same size. Then we can say those two are similar triangles. Then that's back to the case SAS. That's back to the case SAS. For congruent, we need side to be equal. For similar triangles, we need side to be in proportion. Okay, so equal or proportion. And the last one, we have the hypotenuse of two right angle triangle and another pair of the corresponding side are in the same ratio. Okay, same ratio, not same length, the same ratio. Right angle, hypotenuse and side are in the same ratio. We have RHS again. We have RHS again. So for both congruent and similar triangles, we need the angle to be equal. For congruent triangles, we need lengths to be equal, but for similar triangles, we need lengths to be the same proportion. Let's see, that's like a 3-stage. So angle, no, yeah. SAS. It doesn't really matter if it's a right angle or some angle, but if you have two sides and then the include the angle to be equal, that must be SAS. It's not satisfy the RHS. The RHS must have hypotenuse. If you don't have hypotenuse, that's not RHS. Do you know why we really have this RHS? Let's say we have two, let's say C congruent, let's see congruent triangles. Why we have this RHS? Okay, for the RHS, it's actually we know what angle equal, this angle equal. I need congruent triangles. So that are the congruent triangles. So normally we need to have two lengths to be equal and the included angles to be equal. So I have this one equal, I have those one equal. Actually the angle we need to talk about is this angle here. Okay, is this angle here, then that's the SAS case. But actually we don't have that angle to be equal, it's the angle, that angle to be equal. It's not actually satisfy the conditions. We cannot say they are congruent triangles normally, but because that's a right angle triangle and that's special, so that's why we have that. Okay, that's why we have that. But let's think about why our RHS will work. Why RHS will work? Because if you know the hypotenuse, you know one length. By Pasek, you will know the third length, right? So two triangles, right angle triangle, hypotenuse equal, side equal. Why use Pasek? The third one must be equal as well. Actually, it will be back to the SSS case. Does that make sense? Okay, it's actually going back to the SSS case, but we don't want you to show Pasek and work out the length and say that's SSS. We create this rule and telling you, oh, you can use this directly. So it saves you some time, but the basic idea is it is SSS case. It's not nothing to do with that angle. Okay, is that clear? Okay. Okay, so we have learned 4 conditions for two triangles can become similar triangles. And let's go back to the previous page to talk about example 2. Okay, in example 2, a 50-meter tall structure casts a shadow of 30 meters in length. At the same time, a person casts a shadow of 1.02 meters. Estimate the height of this person. Let's say we have a structure here. We have a structure here, and it casts shadows. Casts a shadow here. Cast the shadow here. So that is 50 meters, and that is 30 meters. Okay, that is 30 meters. And then we have a person stand at the same time. You know the light will give you all parallel lines. All the light will be parallel and they will from the same angle to cast shadows for you. So the person got a shadow of 1.02. Okay, 1.02. It's about here. Let's say the person stand here. I can stand in different places, but it's easy to just stand, overlap the shadow with the thing. It's make you easier to understand. So that person is here, and give you that length is 1.02. Let's give all those points a name. A, B, C, D, E. Okay, A, B, C, D, E. So I can see two triangles, ABC and DEC. Okay, that the two triangles. I know the length of EC and BC. Okay, I know the length of BC and EC, and I also know AB. I want to work on DE. This is a very typical shape. Like if you can see, they must be similar triangles. Okay, there must be similar triangles, and all the lengths must be in proportion. But I cannot directly start with writing the proportions because you haven't proved those are similar triangles, and you haven't told me they're similar triangles. You cannot use the properties for similar triangle. So you need to prove similar triangles. Okay, it needs to prove similar triangles. So how we can prove those two are similar triangles? Okay, if we think about that, the building is street standard and the person is street standard, they must be or have a straight angle, like the right angle compared to the ground. So AB is parallel to BC and DE is parallel to BC. Okay, because of that, so the angle ABC must be equal the angle DEC equals to 90 degrees. Okay, because those two are stand straight, so it must make a right angle with the ground. Okay, so we have two right angle triangles. Also, the angle ACB, okay, the corner, okay, the angle of the corner equals to angle DCE because they are the same angle. Okay, actually we talk about the same angle. Those angles both in the triangle ABC, also in the triangle DEC. Okay, that angle is in both triangles. So those two angles must be the same. So the angle BAC must be equals to the angle EDC. Okay, because sum of triangle equals to 180 degrees, and you have two pairs to be equal, then the third pair must be equal. It's not necessary to write the things in the bracket. I'm just making you understand here. Okay, when you read the notes, you know why they are equal. So you have two pairs. Okay, that's pair 1 and that's pair 2. You have two pairs to be equal already, then the third pair must be the same as well. Okay, let's label the corresponding angles because we still need to write all the letters in the order. So we know that angle equals to that angle, and we know this angle equals to that angle, and also the corner, the right corner one are the same angles. So triangle ABC is similar to the triangle. Let's say A is having this D here. Okay, A is corresponding to D. B is corresponding to E because it's the black angle, and C will be corresponding to C because it's the angle itself. So ABC must be similar to the triangle DEC. corresponding lengths are in proportions, in same proportion. Are in the same proportion. You don't really need to write that. Like, you can directly start to write the ratios, but like I just make it looks a little bit easier. So the DE over the AB, okay, the two streets, that one must be CE over CB. Okay, CE is the shorter one in the smaller angle, and BC is the shorter one, is another straight one in the larger triangle. So those two must be in the same proportion. Can you see that corresponding pairs? Okay, they are corresponding pairs, so I can write them in this way. So the ratio must be the same. Then I don't know DE, I will leave DE like that, and I know AB. AB is 50. I do know CE, CE is 1.02, and I do know BC, BC is 30. So I will know what is DE. DE equals to 1.02 over 30 times 50. Okay, times 50 on both sides. That is 3, that is 5, they can cancel the 10. DE equals to, okay, 1.02 divided by 3, that's 0.34. Okay, 1.02 divided by 3 is n times this 5. 1 divided by 3 is 0, 10 divided by 3 is 3, left is 1, 12 divided by 3 is 4, so 0.34 times 5. Then DE equals to 20, 0, 2, 15, 17, and 2 decimals, so it's 1.7. So it's 1.7 meters. Okay, so DE is 1.7 meters. So this person is about 1.7 meters high, because it's estimation. Yeah, if you do AB over DE, that will be CB over CE. So if you totally flip that, that will be the same thing. Okay, so you don't need to really worry about which one on which one. You just need to make sure all the lengths of the larger one on the top or all on the bottom. So if the larger one is on the top, one of that is on the top, all the other lengths in the larger one needs to be on the top, and all the smaller one needs to be under the bottom. Okay. So we have 1.7 for this one. So this is a easy question, but it's not that easy because you need to show all the improvement. Unless the question can directly tell you, okay, there are similar shapes, you will use the properties directly, say they're in the same ratio, start writing the ratios. But because the question haven't tell you that, so you need to prove that by yourself first, and then use all the properties. Okay, and use all the properties. So I have go through 2E. Okay, I will start one questions here, and I'll give you the rest to do as homework during your weekend. So for example 1, I want you to write a proper proof. Okay, I want you to write a proper proof. I know like you understand it, but like you cannot write in your way like you like. There's a particular way you can write things. So now we can see A, B, C, and D, E, F. Okay, for A, B, C, and D, E, F, you have 6 lengths. That must be the SSS case. Okay, it can't be the SAS. There's no angle at all, so it can only be SSS case. So you need to prove that all the all in the same ratios. So let's just roughly have a look. 28 and 7, 16 and 4, 32 and 8. Okay, they are in the same ratios. Okay, they are in the same ratios. So we can write AB over DE equals to 28 over 7, that gives you 4. You cannot directly start to write AB over DE equals to BC over EF equals to AC over DE because you don't know. You need to test first. Okay, so that's my first proportion. And my second proportion will be BC EF. That is 16 on 4 and also give you 4. And the last one will be the longest one is the EC over DF. That equals to 32 over 8. That gives you 4 as well. So if you can't see the pairs, like you can't see the pair, like which one and which one should be paired together, you can say which is the largest one. Okay, that's the largest one. Let's name that number 1. Okay, which one is the largest one in this triangle? Okay, that one must be the largest one. So that's number 1. Okay, which one is the middle one? 28 is the middle one. Which is the middle one here? That one is the middle one. And the third one is 16, so it's the smallest one. So which one is the smallest one? This one is the smallest one. So all those numbers must be in the same pair. Okay, all those numbers are in the same pair. So 28 and 7 is the pair, 16 and 4 is the pair, 32 and 8 is the pair. So you can do this by this way. Okay, so now you have proof that all of that in the same proportion. You can say, so AB over DE equals to BC over EF equals to AC over DF. Okay, I know a lot of you will start from this step directly, but you can't. You need to have this step, those 3 steps. These are the evidence. Okay, that's the evidence. Otherwise, why you can say those 3 are in the same proportion directly? Okay, you need to have the evidence. Okay, so triangle are similar triangles because of SSS. And let's say we have triangle ABC similar to triangle, okay, in the same, like the corresponding points. How we can find corresponding points? Let's say this number 2 is opposite to 28. So let's make that red angles. And that's the red because they are a pair. So 2 and 2 are the pair, so the angles must be corresponding angles as well. So those 2 red dots are one pair. Okay, which one opposite to the green one? That one opposite to the green one. And that one opposite to the green one. Let's make that a cross. Okay, so those 2 must be a pair. And which one is opposite to the blue one? That one is opposite to the blue one. And that one is opposite to the blue one. So they are one pair. So I want to write A, B, C similar to, okay, A is corresponding to D. B is the green angle. Green angle is to E. And the C is the red angle, and red angle is F. So ABC is similar to DEF because of SSS. Okay. The next one is a little bit tricky because it's two triangles are together. So what I will do is I will separate those 2 triangles. Okay, I will separate that. That's A, C, and E. For angle E, I have a cross here. Okay, for angle E is the cross here. And I will draw this triangle as well. That's B, C, D. So that triangle's cross is here. And you know that angle C must be the same as angle C, right? Angle C must be the same as angle C. They are the same angles, even though I take the smaller one out. But it's still that angle, so those 2 angles must be equal. So therefore the last pair must be the same. Okay, the last pair must be the same. I already have the blue pair, the red pair, then the green pair must be the same. Okay. But I still need to talk about that. So angle ACE equals to the angle DCB. Okay, because they are the same angle. The angle AEC equals to the angle DBC because it's given. Okay, the two cross. Okay, that's given. So the angle, the green pair now, okay, CAE must be the same as CDB. Okay, the two green pair, because sum to 180. Okay, you need to have the sum to 180. If you can see, that's all the angles in the larger one, and that are all the angles in the smaller one. So I write things in orders. Okay, I write things in orders. All the larger one in the front, all the smaller one in the back, or the other way around. All the smaller one in the front, all the larger ones at the back. Okay, it makes you easier to think about things. Okay, then I can make the conclusion. So triangle, let's say ACE, okay, the larger one, I'll still start from the larger one, is similar to the triangle. Let's see where's A corresponding to. A is corresponding to the point D. C is still corresponding to the point C. E is corresponding to the point B. So ACE needs to be similar to the triangle DCB. Okay, similar to the triangle DCB. By AAA, because I don't have any length, I just have 3 angles. So that will be similar to the triangle, those two triangles similar because of AAA. Okay, I have finished 2 examples with you and tell you how to write the proofness. You have those 2 questions left in this page and all the next page. Okay, you have 5 questions in total. I want you to do this as homework, and I will check it on Monday class or Tuesday class. I can't remember which day we have lessons, but I will check your solutions. Okay, 5 questions you need to do during the weekend.